Hi class. So we're going to get started on lesson 10.5. This is the last lesson in this section. So we will be doing our test review and getting ready for our unit test for next week. So today we're going to talk about the side splitter and angle splitter theorems. Let's get started. So the side splitter theorem, that's kind of its nickname. It's actually called the triangle proportionality theorem. But we usually just call it the side splitter. But what it says is that if we have a line going through our triangle that's parallel to one of the sides, so this line's parallel to the base right here, then what happens is these two pieces that it broke into two parts right here are going to be proportional to the other two pieces that it broke on the other side. So in this picture, I get a different color out. This distance from A to D, and then from D to B, if I write it in a fraction, in a ratio, AD over DB is going to match the same distance as C to E over E to B here in the orange. So we can use that to find missing pieces in triangles again. So let's look at a couple examples. Example 1. We have this triangle right here, and they told us to find the length from B to E, and they gave us from A to D is 2, and then D to B is 5.5, and then we also know C to E is 3, but we're looking for E to B. So what we're going to do is we're going to set up a proportion again. So I can take the two pieces of this left side, AD, and then put it over DB, and it will equal CE over E to B. And just like in the other parts of this unit, we need to make sure we're lining up the ratios in the right way. So if I put AD on the numerator of my ratio, then I also need to have CE be in the numerator. So just make sure you're lining them up in the right way. But we can plug in the pieces we know. We know AD is 2. So if I plug 2 in, and then from D to B is 5.5. And then CE we don't know, we'll just put that as an X. And then, EC we do know, that one's 3. And then E to B we don't know, and that one's X. So once we have our ratio set up, we just cross multiply. Again, we're doing a lot of that this unit. So again, we can do bottom times the opposite top, and top times the opposite bottom. So if I do 5.5 times 3 for the left side, we get 16.5, and then 2 times x is 2x, and then we just want to solve for x, so we'll divide by 2 first, and then those cancel, and then 16.5 divided by 2 is 8.25, and that would be your answer. Okay, and then let's look at example number 2. They want us to find the length from C to A. So this time we're doing this whole distance right here. So if we still think of this line as being broken up from C to D and then from D to A, if I find this DA piece, I can add it to this 5 right here, and we'll get the length that we need. So we're going to set up our two sides. So I can do CE is 6 over E to B is 9. And then because I put CE on top, DC needs to go on the top of the other one. So 5 will go on the top. And then X over here. And we cross multiply again. So we get 9 times 5 is 45. And 6 times X is 6X. And then to get rid of the 6, we'll just divide by 6. And then 45 divided by 6 is 7.5. So I just need to be careful and make sure that's not my final answer. I'm not done yet. We just found that this piece right here is 7.5, but they wanted the entire length. So we need to do 5 plus 7.5 to get our total side from C to A. So 5 plus 7.5 is 12.5, and that is going to equal your distance from C to A. So there's that one.